Welcome to qnawire.
To calculate the delta H for the reaction between ATP and water with the given information over here, we're told that the delta T is going to be equal to 1.49 degrees Celsius. We also know that the heat capacity of water is that of 4.19 joules per gram degree Celsius. And in this case, the delta H of the reaction in molar would be equal to minus the heat released divided by the amount of mole that we're going to have. This is the expression that we are given on this section over here. So the delta H of the reaction is going to be equal to minus mass in the mixture that we're going to get times the heat capacity, we're employing the heat capacity of water in this case, times the value for delta T. We're dividing by the number of mole that we're going to have. First of all, the mass of the mixture, we can assume that the density of the mixture is approximately equal to the density of water of 1 gram per milliliter. So since we have 81 milliliters, we're going to have 81 grams. This is why it is very important to use always the units over here when you're doing your calculations, because in any other way, you're not going to be able to identify this type of mistakes. Next up, the heat capacity of water is 4.19 joules per gram degree Celsius times the value for delta T in degrees Celsius, 1.49 degrees Celsius. And now, by the amount of mole, since we're looking at the reaction between ATP and water, the limiting reagent is going to be ATP. So, the amount of mole corresponds to the amount of mole of ATP that we're going to have in our sample. So this amount of mole would be equal to the volume in liters times the concentration in molarity that we're employing. We're using 80 times 10 to the minus 3 liters and a solution of 0.3 mole per liter. So the amount of mole of ATP would be equal to 2.4 times 10 to the minus 3 mole. So 2.4 times 10 to the minus 3 mole. Notice that the units are going to cancel out correctly. Grams cancels with grams, degrees Celsius with degrees Celsius, and our final result is going to be in joules per mole. So we're going to get 210,704.6 joules per mole, or if we want, 210.704, also 746 kilojoules per mole of ATP. And this would be the heat of the reaction calculated correctly. With that, it would be all. Thank you very much and have a good one.